All right, welcome to this explainer. Grab your headphones, settle in, because today we are diving into CFA Level 1 quantitative methods, specifically Learning Module 5 Portfolio Mathematics. Look, the goal today is to make your active studying an absolute breeze by zeroing in on the intuition behind covariance and shortfall risk. Put the calculator away for now. Just listen, absorb the concepts, and let's figure out what these numbers are actually trying to tell us. Okay, let's dive into this. Up to now in your quant studies, you've probably stared at variance and standard deviation a million times to measure individual risk, right? But when we start building a portfolio, looking at things in isolation just doesn't cut it anymore. We have to ask a much bigger foundational question. When one investment moves, what tends to happen to the other one? That right there is exactly what covariance answers. We're shifting gears from individual risk to how these investments behave together. So, at its core, covariance is just a measure of how two investments move relative to one another. Think about it like this. If you own two really wild, highly volatile stocks, but they jump up and crash down at the exact same time, bundling them together doesn't actually give you much diversification. But if you combine assets that behave totally differently, maybe one zigs while the other zags, well, that is where the magic happens. Covariance is literally the key to unlocking that diversification. And this brilliantly illustrates the two main outcomes you're going to see. Positive covariance, that means things generally move in the same direction. When asset A is having a stellar day, asset B is usually riding that exact same wave. Negative covariance, on the flip side, means they tend to move in opposite directions. Asset A goes up, asset B goes down. It's a beautifully simple concept, but it is an absolute game changer when you're trying to build a solid portfolio. Now, you're definitely going to be asked to calculate covariance from a joint probability distribution on your exam, and for sure you need to practice the mechanics of that calculation during your active study sessions. But for your passive review right now, just remember the why. Portfolio risk depends on how investments behave together, not just their standalone risk. By mixing assets that react differently to the market, you can actually reduce the overall volatility of your entire portfolio. That is the fundamental idea behind diversification. All right, moving into section 1, covariance matrices. In organizing the relationships. Now, reading a covariance matrix sounds intimidating, but it's really just a handy tool for mapping out interactions across multiple assets. Picture this. You've got 3 asset classes in your portfolio. Let's say the S&P 500, U.S. long-term corporate bonds, and the MSCI EAFE index. With 3 asset classes, you would create a 3x3 matrix, which gives you 9 little cells. Honestly, all this matrix is doing is throwing every single possible pairing of those 3 investments into one grid. So instead of a messy, chaotic list of separate relationships, you get a clean, neat table showing exactly how everything interacts in one single place. So the crucial point is this. Do not overcomplicate this or try to memorize complex matrix algebra. There are literally only 2 golden rules you need to remember for exam day. Nail these 2 bullet points and you can navigate any covariance matrix they throw at you with total confidence. Rule number 1. The matrix is perfectly symmetrical, meaning the covariance of asset A with asset B is exactly the same as the covariance of asset B with asset A. The order totally doesn't matter. If you know the covariance between stocks and bonds, you inherently already know the covariance between bonds and stocks. It's the exact same number just mirroring itself across the grid. They aren't 2 different relationships, it is just the same covariance showing up a second time. And rule number 2 is all about that diagonal line running right down the middle of the matrix. Ask yourself, what actually happens if we calculate the covariance of an investment with itself? Like, what's the covariance of the S&P 500 with the S&P 500? Well, that's just the variance of the S&P 500. So the diagonal line just tells you about the individual investments, their variances. Any number away from that diagonal tells you about the relationships between the different assets. Okay, let's hit section 2, shortfall risk and protecting the minimum return. This takes all our portfolio math and pulls it into a super practical, real-world scenario. Shortfall risk asks a really direct practical question. What is the actual risk that my portfolio return falls below the absolute minimum return I need? Imagine an investor tells you, look, I need my portfolio to earn at least 5%. Sure, they'd love to earn way more than that, but they are terrified of falling below that 5% floor. Now, a specific portfolio might have a massive expected return, but if it also has massive, wild volatility, well, that wild swing seriously increases the chance of missing that 5% target. So in this case, the highest expected return isn't necessarily the best choice for them. Now, what's really interesting about this slide is how we solve that exact problem using Roy's safety-first criterion. This is the tool we use to compare different portfolios by looking at three specific things: expected return, minimum required return, and risk, which we measure by standard deviation. Conceptually, it's great. It just calculates your return cushion and then divides it by your risk. Let's break down that intuition so you can see exactly what the formula is doing behind the scenes. Step 1, you find the portfolio's expected return. Step 2, you subtract the investor's minimum required return. That difference, that is your return cushion. Literally just how much the portfolio's expected return exceeds the bare minimum the investor requires. Finally, step 3, you divide that cushion by the standard deviation. We are basically asking how much expected return do I actually have above my minimum requirement relative to the amount of risk I'm taking to get it. Let's move to and see how this spills into an absolutely essential exam tip. For Roy's safety-first criterion, higher is better. A larger return cushion relative to your risk is exactly what you want. But, and listen up, because the exam will try to trick you here, remember back in Learning Module 3 when you covered the coefficient of variation? For that one, the decision rule is the exact opposite. Lower is better. You have to keep those straight. Safety first goes higher, coefficient of variation goes lower. All right, let's wrap this up and bring it all together. Here are your key takeaways for this passive review before you sit down with your calculator. Positive covariance means assets move in the same direction. Negative means opposite directions. When you're looking at a covariance matrix, remember it's perfectly symmetrical. Covariance AB equals BA, and that diagonal line running through it is simply the variance of the individual assets. Finally, for Roy's safety first, you are measuring the return cushion divided by risk, and higher is always, always better. Remember to practice the heavy arithmetic separately during your active study. Understanding what these measures actually mean right now is going to make those calculation questions so much easier later. Well, I hope this explainer has given you the calm confidence you need to tackle portfolio mathematics. If you found this helpful, hit like and subscribe to Designation Buddy for more passive learning modules. But hey, before you take off your headphones, think about this. If adding a negatively correlated asset lowers your portfolio's overall risk, is it ever mathematically justifiable to add a highly volatile, risky asset on purpose? Ponder that before your next active study session, and we'll see you next time.